Okay, I'm going to teach you a little bit about molarity. Molarity is another concentration type formula. So we have several different ways to measure concentration. We already talked about percent by mass, percent by volume, percent mass by volume, and now we're talking about molarity. They all have something in common. They're all ratios of a unit of solute per a unit of solution. If it's percent mass, it's mass solute, mass solution. If it's percent volume, it's volume solute, volume solution. With molarity, we get a little bit different. Moles of solute, and the bottom has to be in liters of solution. So it's volume, but not any old volume. It can't be, it has to be liters. So molarity is used to describe the concentration of a lot of solutions. We like it in chemistry because chemists use moles. So don't forget, this is one of the parts, this is the whole thing. So we have solute and a solvent together make a solution. And it's really important to identify the solute and the solution. We use it in chemistry because we do stuff in moles. If we know how many liters, and we know the molarity of the solution, I know how many moles I have. So let's say I had a 3 molarity solution. That means 3 moles of solute for every liter of solution. If I had 5 liters, and each liter had 3 moles, then I have 15 moles total of solute. I'd have a lot of solvent too, but I have, what we're normally thinking is maybe I have a solution of hydrochloric acid, or maybe I have a solution of NaCl. And NaCl is the chemical reactant that I need to actually react. And then there's a solvent of water. I'm only concerned about how much of the chemical that's going to react is in there. So a lot of times I'll use molarity, but I really just care about how many moles of the solute that I have. It's abbreviated with a capital M, so when we see this 6.0 M, and we pronounce it molar. So this would be pronounced 6.0 molar HCl solution. Now there's an awful lot implied by this. One, the molarity is 6, so that's 6 moles per liter. Also, the solute is HCl. Whatever is labeled here, that's telling me my solute. Probably it should have aqueous written after it, which would mean that the solvent is water. So that means for every liter of this mixture, 6 moles of HCl are in it, of just the HCl solute. I will tell you, it's very helpful. Remember, we're practicing using our units, making sure our units cancel out. We can always replace a capital M with this unit, moles per liter, because that is the units, moles per liter would be the correct units. So, and that way, if I'm multiplying or dividing, just the moles or just the liters can cancel out. Also, it hints that we can use this as a conversion factor. 6 moles per 1 liter, 6 moles of HCl per 1 liter of solution could be used as a conversion factor. All right, so sometimes you'll be given a task to calculate molarity, and I'll give you the moles, and I'll give you the liters of solution. I'll give you the moles of the solute, and I'll give you the liters of solution. Other times I might give you grams of solute. So if I'm given mass of the solute, and I'm also told what the total volume of solution is, I don't have directly enough to plug in, but I do have enough. If I had 60 grams of NaCl and I dissolved it to make exactly 2 liters of solution, 2 liters of solution, that's my liters of solution that can go into that equation. I need to figure out how many moles of solute, and this is implying that NaCl is the thing I'm adding, that's my solute. What would be the molarity of the solution? So I'm going to need to get moles, but we've spent time with this. We know how to go from grams to moles using the molar mass. So again, I'm given molarity. I'm looking for molarity, I'm given grams of solute, I'm given liters of solution. Be very careful, it's really important to be first identifying what is the solute, what is the solution. I know that grams and moles are related by molar mass, and I know that the molarity has formula is moles of solute per liter of solution. So I'm going to first convert grams to moles. So 60 grams times 1 mole per 58.44 grams of NaCl, I got this molar mass from looking at the table. That turns out to be 1.027 moles of NaCl. So now I can use the molarity equation and plug it in. Molarity is moles over liter, it's moles of solute over liter of solution. So that's 1.027 moles of NaCl per 2 liters of solution, or 0.514 moles per liter. I can now take that moles per liter and change it out for the abbreviation capital M. 0.514 capital M NaCl. NaCl would be telling me what is the solute. Often we identify the solutions by their solute. What is the molarity of a solution made by dissolving 3.6 grams of KMnO4 to a volume of 750 milliliters? Similar problem. Again, I'm given grams of solute, I'm given liters of solution, or I'm given volume of solution. KMnO4, that's going to be my solute. It doesn't say what the solvent is, so we can probably assume it's water. Again, I'm going to start off with moles of X is equal to grams of X per molar mass of X. I think I hid some stuff on here. I know that I have 34.6 grams of KMnO4. I know that there's 750 milliliters, and that they're just saying the solution was made by dissolving to a total of 750 milliliters, so that 750 milliliters is talking about the solution. It's telling me KMnO4 is the solute. To a volume of is my hint word saying that that's talking about the solution volume. So I'm going to first find the molar mass of KMnO4, 158.04. And then I'm going to take my molar mass is the grams divided by the molar mass. So 34.6 divided by 158.04, I get 0.219 moles of KMnO4. Instead of dividing this, I could have used this as a conversion factor with grams on the bottom. It would still be dividing. And now I'm going to plug that 0.21. Now that I know how many moles I have, I can use that to put in for moles of solute. That's my moles of solute, my liter of solution. Watch this. We have to be very careful. We have to get very good at this point from going from milliliters to liters. All of our equations for molarity need to be in liters. So convert that 750 milliliters to liters, 3 decimal points to the left, or I can set it up. I know that there's 1,000 milliliters per liter. And when I take 0.219 divided by 0.750, I get 0.291. Here I have moles per liter are my units, but I know I can replace moles per liter with capital M for molar. I missed my strategy. Oops. How many moles of HCl are in 25.4 milliliters of 6.0 molar HCl? Let's strategize this one. I need moles of HCl. I'm given the volume of solution in milliliters. I'm given the molarity. And I know molarity, 6.0 molar HCl, could be written as 6.0 moles of HCl per liter of solution. So that could be a conversion factor. I can use molarity as a conversion factor. I could also use the molarity equation and plug in the two things that I know. I know the molarity and I know the volume of solution if I convert this to liters, and then I can solve for moles. I'm going to use the conversion method. So since this is going to be my conversion factor, I'm not going to start with this. That means I'm going to start with a 25.4 milliliters. So 25.4 milliliters, I need to convert that to liters. I know I need to convert that to liters because when I look up here, I realize my conversion factor is in liters of solution, so I need to have it in liters. Then I take 0.0254 liters of solution. Again, watch the units. I want liters of solution to be on the bottom. When I look at the way I've written this out, liters of solution is on the bottom, so I do not need to flip this. Times 6.0 moles of HCl. The liters of solution are going to cancel. I'm going to be left with moles of HCl, and I get 0.15 moles of solute. And in this case, the solute is HCl. So you're going to see these two equations a lot. You really should have both forms memorized. My traditional molarity equation is molarity is equal to moles of solute per liter of solution. Doesn't have to say mx, but whatever it is. If I rearrange this, I can take this equation and multiply both sides by liter, liter of solution, liter of solution. On this side, they cancel, and I'm left with moles of solute. And on this side, I have liter of solution times molarity. Now I'm just going to rearrange this to another. I just flipped the side of the equation. Moles of solute is equal to molarity times liter of solution. Both of these are handy. So if the question is asking me to find molarity, I'm going to use this equation. If the question is asking me to find moles of a solute, and it might not say it's the solute, I might have to interpret what is the solute and that it wants moles of solute, then this is going to